Okay, let's continue with the problems on the last slide. Problem 1. How much energy is given off when 23 grams of steam at 115 degrees Celsius is converted into ice at -2 degrees Celsius? Okay, in the previous problem, we were going from ice to steam. In this problem, we're cooling. We're going from steam to ice. I wanted to show you both directions so that you're not caught by surprise if you see this kind of problem. The first thing that I need to do, once again, is convert the 23 grams of water into moles of water, because I'm going to be using that 23 grams. And I know that 1 mole of water weighs 18 grams. My grams will cancel. That gives me 1.28 moles of water. Okay, now that I have that in moles, I can once again go back here and calculate each step. So this time I start with steam at 115 degrees. So I'm cooling off. I'm going in the opposite direction. I'm first of all going from from 115 to, if I cool off, it's going to condense, or it's going to give off energy until it hits steam at 100 degrees Celsius, because that is the point where my steam is going to start to condense, because that's the boiling point of water. And it's also the condensing point of water, okay? Because now I'm going in the opposite direction. For these, as I said, the slope parts of the graph, I'm going to be using Q equals MC delta T, but the C is that of steam. So my first step is equal to MC for steam times delta T. Now let's look at this. The mass is 23 grams times the C for steam, which is 1.87 joules per gram degrees Celsius. Now let's talk about the change in temperature. I start at 115 and I end at steam at 100 degrees. So that's my final temperature, is 100 degrees minus 115 degrees. That's where I started. Degrees Celsius. That cancels out, grams cancels out, and if you do the math, I will have, or should have, minus 645.2 joules. Notice the negative sign. Don't be afraid of the negative sign. Just think about, in chapter 9, we talked about the sign convention. If we have a negative, that means that heat is being given off, which makes sense. If I'm cooling the heat, or if I'm cooling the steam is giving off that heat, and that's why it's a negative sign. Let's convert this to kilojoules, and I do that by 1 kilojoule is 1,000 joules. My joules will cancel, so basically I just divide by 1,000, minus 0.65 kilojoules. That's my first step, where I take steam from 115 degrees and I cool it to 100 degrees. And now that I'm here, steam at 100 degrees, it's going to continue to give off heat till it reaches water liquid at 100 degrees. So I'm going in the opposite direction. Now, there is no sign change necessarily associated with this, because I don't have a negative delta T, because I don't have a delta T for that part of the curve. But I know that the energy is being given off, so all of these values are going to be negative. Even though there is no delta T here, it's going to be a minus because it's in the opposite direction. It's being cooled off. So Q2 N times delta HV is going to be N 1.28 moles times 40 and I should have done it up here. is equal to minus, that's for the cooling part, 40.7 kilojoules per mole. My moles will cancel, and this will give me a negative value of 51.9 kilojoules. Okay. Now that I have, so note, once again, don't forget the sign, because I know a lot of students will forget the negative sign here because there is no negative temperature change, so they'll leave it as a positive number, and then at the very end when they add all the steps together, they'll have a wrong value because they have positives for these. But because all of the numbers, they're either going to be all positive or they're going to be all negative because you're going in that direction. So they're all going to be a negative. It's either a negative value for all of them because you're cooling, or positive value for all of them because you're supplying energy to the system. Okay, so for part one, so step 1 and step 2, I went from steam at 115 degrees to water liquid at 100 degrees. Now I enter the sloped stage, or the sloped part of the graph again with the liquid. So I'm cooling off the liquid from 100 degrees and I take it all the way to 0 degrees Celsius. Therefore, my third step will also use MC delta T, M, but the C is going to be that for water. C for W for water times delta T. The mass doesn't change, 23 grams, times C for water is 4.184 joules gram degrees Celsius, times delta T. Let's think about the delta T. I start at 100 degrees and I end up at 0 degrees. So my final temperature is 0 minus the initial temperature is 100 degrees Celsius. Therefore, I'll have a negative sign for this as well. This will be minus 9,632 joules. To convert that to kilojoules, I divide by 1,000, and that gives me minus 9.6 kilojoules. That's my third step. I have taken steam after these 3 steps from 115 degrees all the way through the phase change. I condensed it to liquid, and now I have liquid at 0 degrees. I'm right here. My next step will take liquid water from 0 degrees and freeze it to get it to ice at 0 degrees. Once again, there is no temperature change for this, so you can't do a negative temperature change to know this is negative, but you know it's negative because you're cooling. Therefore, the water is giving off the heat, so this will be a negative value. Q4 will be minus N times delta HF, minus 1.28 moles times the delta HF is 6.01 kilojoules per mole. My moles will cancel, and this will be minus 7.69 kilojoules. Oops. Okay. Now after step 4, I have ice at 0 degrees, and I'm taking ice all the way to -2. The last step, therefore, so Q5 is going to be, once again, the slope part, Q equals MC delta T, M times C for ice, because now I have ice, times delta T. Mass is 23 grams times the C for ice is 2.03 joules per gram degrees Celsius. My grams will cancel. Now let's talk about the change in temperature. My final temperature is -2, so -2 minus my initial temperature, which is 0. So this is going to give me 2 minus. Okay. And once again, that's going to be a negative number, and it's going to be minus 93.4 joules. To convert that to kilojoules, I divided by 1,000. And that will give me minus 0.093 kilojoules. I have the last step. And now all I have to do to figure out the total amount of energy, I'm going to be doing this up here. I'm going to wipe this part, is just add all of the Q's together to give me the total amount of heat that is given off. As you can see, if you had these two values, so this one and this one, as positive numbers, then that would throw off the total. My total QT is Q1 plus Q2 plus ... Q5, and it's equal to a total of minus 69.98 kilojoules, or let's see, it will be minus 70.0 kilojoules with significant digits. That is the total amount of heat, of energy, that is going to be given off if I cool 23 grams of steam from 115 degrees all the way to below, so minus 2 degrees Celsius, to ice at minus 2 degrees Celsius. Okay, this was another one of the long ones, but it was in reverse, and I wanted to show you how to do these types of problems in reverse, where you're giving off steam, or you're giving off energy instead of pumping energy into the system. And so all of the values, the Q values, are going to be negative to reflect that. The next two problems are not going to require all of the 5 steps. They're going to be a little simpler. So I'll erase this, and then we'll start with problem number 2.